Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by a very special guest who'll be getting a full introduction just after this official intro. We have Ethan Siegel from Starts With a Bang fame. We are tonight broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. As a reminder, York Universe broadcasts every Monday night live at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT if that's more your speed. We are, of course, broadcasting in conjunction with our online public viewing on YouTube at York U Observatory, and that program is run by our amazing observatory team. So if you're joining us live for the broadcast, welcome to YouTube and feel free to ask any questions in the chat. If you're listening to this as a podcast later, well, you can always catch out any visuals you might have missed over on the YouTube channel. As a little FYI, to navigate to the live show or to find out more or listen to past episodes or see really cool JWST videos, you can actually check out our website at yorku.ca/science/observatory and follow the links to OPV for online public viewing or click on any of our YouTube links on the site and that should take you to the right spot. Now, for any questions or comments you have about our past shows or suggestions for future topics, you can always email us at observe@yorku.ca. You can also find us at an Instagram at YorkU Observatory, Facebook at Allan Carswell Obs, and of course, back on that same website I mentioned before, yorku.ca/science/observatory. Now, all of our programs are free, but since it is actually the fundraiser time of year, I do have to mention on that very same website, we are currently running a amazing first ever online Allan I. Carswell Observatory fundraiser. Now, you might wonder why are we running a fundraiser? Well, it's all in there. There's a whole bunch of goals, stretch goals, and repairs, refurbishments, pieces of equipment that we're hoping to actually get. So our first goal is 5,000 Canadian dollars, and this will allow us to continue our free every Wednesday in-person tours through the end of April, as well as a little bit of extra free high school tours. And the celebration will include free digital swag because we love free stuff, which we'll be putting on the website, and a draw of both the private tour raffle, which is obviously free, and the supported observing raffle, which you can win a night of observing with the AICO crew, fully supported with your own data. There's also a super swag raffle, which is a one-time draw only. So all of that is happening right now, and I just have to give a little extra shout out at the start of this York Universe. Now, this has made a bit of a longer intro than usual, but I think it was for a very good cause. So now we're going to go ahead and get into the main part of the show for today. And now a little bit about our guest. So tonight, as I mentioned, we have a very JWST themed episode. We've got Ethan Siegel with us tonight. And if you haven't seen the Starts With a Bang website, I highly recommend it. It's at startswithabang.com. He's done a tremendous amount of outreach and science writing, and of course, an astrophysicist by training. He will be a wonderful person to talk to about JWST this evening. And of course, we have a whole giant show. So his website, bigthink.com, is, I believe, where you start off with to get to Starts With a Bang. And he also has a podcast, which I have to give a shout out as well because I was actually on there not too long ago. Ethan, welcome to York Universe.
Thank you, Elena. Thank you, York University and York Universe, for having me here. I think this is so exciting. I would be ashamed of myself if I missed a chance to talk about JWST and the amazing new scientific finds that it's bringing us. But I am just so excited to be here. Elena, you maybe did not mention that you were my podcast guest on an episode that went live just 2 days ago. So you are my most recent guest. And if you want to check out the Starts with a Bang podcast, that is on SoundCloud, on Spotify, and anywhere podcasts are streamed. And of course, you can always check out my latest writings at bigthink.com, which has been hosting Starts with a Bang since 2021.
Amazing, yes. And of course, tonight we're hoping to open the 1 meter telescope, but since the clouds in Toronto have been a little bit uncooperative, we have gone ahead and put up some archival images over on OPV on the YouTube channel. So if folks are joining us later, I'll just go ahead and say that we have actually managed to get JWST imaging at the 1 meter at the Allan at Carswell Observatory. And you might think, how is this so? Well, we have a little bit of a hack, which is that we literally just looked at the JWST satellite in its orbit at L2 with our telescope. And it is bright enough to see. We can watch it go through the sky. And tracking satellites is a really fun project for all kinds of different sizes of telescopes. So if you would like to see what not necessarily a JWST image directly looks like, but what JWST looks like when it's taking images through our telescope, well, we can actually show you that with a short animation. So that's up on our OPV, and it's also on that same website I mentioned as a GIF. So just a little bit of, I suppose, telescope fun or telescope tag, if you will, watching one telescope with another. And one of the great things about JWST and seeing it going around in its orbit, and actually we should, as we're going through this episode, just start off by saying, for those of you who maybe haven't done as much with astronomy, JWST is in fact the acronym for the amazing James Webb Space Telescope. Now, this telescope has had an amazing history. So, Ethan, I think for this episode today, what I thought would be fun was to maybe walk through a little bit of the interesting history of JWST. Now, as far as I can find, the first real start to JWST was back in 1996, where we had a committee recommending a space telescope. And because usually we do This Week in Space and Astronomy History, I try to find something near the same date. But 1996 was for sure an important year on the path to JWST. This was actually the end of the committee, the HST and Beyond Committee's report. So this is the Hubble Space Telescope, which of course we've all seen amazing pictures from. But what's after Hubble and what would be next? So the HST and Beyond Committee's report ran from January 1st, 1994 through December 31st, 1996. So on today, 1996, they were working on this report and about to finish it at the end of this month. All right. So we
Nothing
have
like a 3 year long committee to say, like, okay, we're in the final month, you better get it done.
exactly. So this week in space and astronomy history, 1996 would have been a pretty exciting time for people who had been on this committee all that time. And they did recommend, as a successor to Hubble, a larger telescope with the ability to take ultraviolet, optical, and infrared images. And NASA selected the Goddard Space Flight Center and the Space Telescope Science Institute to do a study on feasibility and see, is this possible? And there are actually some really nice archival images that you can find from early concepts that were published by Pierre Belli and Peter Stockman. And you can actually still find them on the STSCI, which is the, make sure I get my acronyms
It's the
correct,
Space Telescope Science Institute. I'm happy to
yes,
save you the I'm happy to save you the trouble on that one. That is where
acronym
in the
quiz.
United States they manage all of the space telescopes from Greenbelt, Maryland.
Yes, and of course, as any good astronomer would know, if you've got your astronomy acronym bingo cards out, you will be able to completely fill it by the end of this talk because we do have a lot of acronyms all over. But yes, they did actually suggest that we put in a large deployable mirror, and in 1996 they officially suggested 8 meters and an L2 orbit. So one of those two things we actually got, not the 8 meters, unfortunately, but they had an open telescope design and it would all be behind a multi-layer sun shield. And the design looked a bit different, but it also looks really, really similar. So it's kind of a small piece of JWST history. And that's, of course, 1996. So I always have to stop when I'm going back in time and go, right, 1996. Okay. So are there any really big JWST moments that you would put before 1996, Ethan?
Oh boy. So you have to recognize, right? Whenever we talk about astronomy and facilities of any type, especially when we're talking about flagship facilities, whether on the ground or in space, there's a term that scientists think about all the time that the general public almost never ever hears. And I want to introduce all our audience here to a term you may not have heard before, and I call it discovery potential. What is discovery potential and why do we care so much about it? I want you to imagine the whole range of electromagnetic wavelengths, not just this visible light we can see, and not just a little shorter wavelength of ultraviolet and a little longer wavelength of infrared, but that whole multi-wavelength spectrum: gamma ray, x-ray, ultraviolet, optical, near infrared, mid infrared, far infrared, microwave, and radio. Imagine that whole thing all stretched out. And then you say, okay, I want to know with our current facilities, our current capabilities on the ground and in space, what are we limited by? How good at maximum were we able to get in terms of resolution, in terms of light gathering power, in terms of sky coverage, in terms of any metric you can make? How much can we currently discover with what we have? And you look at all of that, and then you say, where, if I were to build a new one now with my big ambitions, with how much money I have to invest in it, with how much technological capabilities we have, what's the next thing I can build? And that's what astronomers think about when we think, what are the things we should focus on? So when it came to the mid 90s, and for those of you who want to know how old I am, 1996, in December of 1996, I was a freshman in college, and now I'm closer to 50 than I am to 40. So that's what's happened since 1996 for me. And for all of you, well, we had a few space telescopes already. We had the Compton Gamma Ray Observatory, and we had the Hubble Space Telescope, which had its servicing mission, already at the end of the early 90s, at the start of the mid 90s. That had already gone through. We still didn't have the Spitzer Space Telescope. We still didn't have the Chandra X-ray Observatory, but we were already looking ahead. Hubble was going to go into the infrared, but Hubble could only go a little bit into the infrared because it was warm, because it was in orbit around the Earth, and the Earth always radiates. Sure, it's wrapped in what looks like aluminum foil. NASA calls it thermal blanketing, but if you guessed it's aluminum foil, you wouldn't be far off. Um, but you say, I want to go better. What can I do that's better? Well, Spitzer did a little better because Spitzer could go to longer wavelengths. It had a cryo cooler on board. It was farther away from Earth than Hubble is, but Spitzer was tiny. And so we said, now we have to plan for a new flagship observatory. What do we want it to be? And they said, in terms of what we're building, in terms of what we can do, in terms of what we've got planned, if we could build a large mirrored space telescope, and we could put it in orbit at the L2 Lagrange point, and we could build state of the art instruments. We can really like improve what we've seen by factors of hundreds or thousands over previous observatories. And that was for me the big motivation for JWST. Back then it was called NGSD and ST, for the next generation space telescope. And as someone who is a huge Star Trek The Next Generation fan, I thought this is going to set us up for the ultimate crossover. They changed the
Absolutely.
name and they changed the design, but I wasn't really worried about that. You know, part of changing the design is a good sign, because it means that your technologies are maturing and you are changing your plans to adapt to the new technologies that you have. When we were talking about the mid 90s, when we were designing JWST, we were like, oh, well, it'll have to launch on the space shuttle, or maybe it could launch on a Soyuz rocket. And if that sounds like a very old fashioned 20th century sentence, that's because it is. So we said, okay, well, we're going to have this much bigger rocket now, this Ariane 5 rocket. They're up to Ariane 6 now. There are no more Ariane 5s. And so the James Webb Space Telescope has to fit in there. So they came up with a segmented mirror design that could fold up and fit in the rocket. The plans for a sun shield were brilliant, because when you look with your telescope, Elena, with your 1 meter telescope at JWST, you're seeing the hot side. You're
Oh,
seeing
yeah.
the side that is on the hot side of that 5 layer sun shield, because JWST always has its butt, has its hot side facing the earth and the sun. The side that faces away, that faces the broader universe, is the cold side, where all the optical assembly is and where all the instruments are. And that's where everything comes through. The light gets collected, it comes into the instruments, and it shows it. So, you know, if you want to talk about big milestones, the early history is really, you know, it's fascinating. For me, the biggest moment came in about between 2011 and 2013. There was worried that, you know, they said, here's what we're going to build, here's how much money we need. And of course, they didn't build in what we say are appropriate margins, which is to
Yeah.
say, when you plan on a project, things cost more in the end, because things don't always go as planned and you need to adapt for that. A good planned mission will have about 20% of your budget built in for margins. JWST didn't really have that. And so they went to Congress and they said, hey, listen, we're having some problems here with our funding. If we want to keep this mission on schedule, back then it was scheduled to launch in 2014. They said, we're going to need $250 million this year and $250 million next year, and that will get us back on track. And when that money didn't come in, that's when all of the real financial problems happened. Because without that money, not only couldn't they do the work, but they couldn't pay the people whose skills and experience they needed to do that work. And so that's when the cost of the mission ballooned from what was going to be 5 million to more than 8 billion. It's this lesson that we hate and we learn over and over again in everything we do, that when someone tells you it's going to be more expensive than you thought, if you try and pinch pennies there, you are being penny wise and pound foolish, because not only did they not get the telescope completed on time for that, but they lost a huge number of scientists, engineers, and people essential to the project that they then had to go rehire and train new people to do this. So, you know, I was just happy, really, really happy when they did all of those robust tests and screws fell out, because it means they caught it on the ground. And when fasteners didn't release when they were supposed to, that was great, because that meant that's a mistake that we're going to fix before we launch it, rather than something that's going to happen up there. Because once that telescope is launched and once it's out of your control, everything has to work right. We've got one of these, it's almost a $10 billion project, and it really has to work. Once it's out of your hands, you can't fix it. So everything was really going to come down to that Christmas launch in 2021 and the subsequent deployment that would happen throughout the first half of 2022.
Oh yeah, absolutely. And of course, it is just so interesting to see how it all came together. And I mean, it is interesting as well from a history perspective that there does seem to be a lot happening in Decembers throughout the year, which made a little bit of compiling this week in space and astronomy and history kind of easier than I thought it would be, because not only did they, as you say, it was just such an interesting time, and at the end of the 90s, they were already getting into all kinds of interesting stuff, and then as Next Generation Space Telescope was its name until about 2002. And then of course they renamed it, but it was just such an interesting project. They did actually have one thing that I was able to find before 1996 as part of this project, and that was in 1989. They actually had an NGST workshop, which was to discuss a 10-meter successor to Hubble with UV, visible, and IR. Now, if they had gone ahead with 10 meters, it probably would have taken even longer. At least that's my impression for JWST to finally get built. But
I'm also glad, by the way, that they didn't keep the commitment to a UV optical IR observatory,
mm,
because if they did that, it
yeah,
would have been a real challenge to get as far into the infrared, to get all of the near infrared spectrum and so much of the mid infrared wavelength range into your observatory, right? It's that problem you have where if you build your observatory to be all things to all people, not only are you going to have an even bigger oversubscription problem, but it turns out it's probably not going to perform as optimally at all of the things as if you build a more specialized observatory. So I, for one, am personally very glad that they said, no, no, this is primarily infrared and we'll go a little into the optical, but that's our sweet spot.
yeah, they're going to do one thing and do it well. And so, starting off in 1989 with a very general UV visible IR 10-meter thing, and then paring it down already in 1996 to an 8-meter. They of course had their 1999, so that 10 years after the original NGST workshop, they had their partners and engineering firms coming up and doing concept studies for a launch in 2007. So that was the first real launch date proposal that I could find, because it really was such an extremely interesting process. People like to call it the near-death experiences of JWST, things that could have killed it and didn't, but people came in with such incredible interest and such incredible, I would say almost community, to really, really bring this back in and support it. And so we saw, of course, this going on from the 1999 concept studies through to 2002, and they had, of course, the renaming, and then in 2004 they had started construction on some of the long-term work for, in particular, I believe the 18 segments on the primary mirror, and that's of course when the Ariane 5 was around about when the Ariane 5 was approved. That was 2005. And I think in 2005, and maybe they were still hoping for a 2007-ish launch. And the price tag
You
at
got to
that
be
point
really
was about a
careful with
billion
this, right?
dollars.
Realistically, you have to be careful with that, because what it sounds like you're looking for historically is, when did they give new dates? And you're not looking at, realistically, when did they think was a realistic date at that moment in time, right? So they knew Look, we've never built a deployable telescope in space before. That's going to take time. We have plans for the instrument suite that's going to be there, but the instruments are not yet constructed. And so it takes time to build instruments. In fact, any instrument builder is going to tell you that the time it takes to build your instrument scales with the size and mass of the instrument. So we knew this telescope was going to need big, powerful, and expensive and labor and time intensive instruments. And we knew as soon as we said, we're going to build this sun shield, that this was something we had never done before. We had never had a passively cooled space telescope. To give you an idea of how impressive this thing is, right? It's constantly in direct sunlight. And with the 5 layers that it has, the hot side is almost hot enough to boil water. It's like 300 and something Kelvin. It's significantly hot. And yet if you go to the cold side, it's below 40 Kelvin. It sits around, it hangs out in the 30s of Kelvin, which means it's way below the temperature of liquid nitrogen, right? So this is extremely cold. And so to have something that does that, they needed to be the size of a tennis court. They need it to be this very special passive fabric that vents heat out of the sides, and they need it to, have tension so that the heat stays in between the layers and vents out the sides instead of passing through from the hot side to the cold side. And even with all of that, they say, okay, that's good for all of the near infrared stuff. But if we want to go to the mid infrared, even at 30 something Kelvin, that produces too much thermal noise. So the mid infrared instrument has its own dedicated cryo cooler that keeps that instrument no warmer than 7 Kelvin. And so that's what you need. So when you say, like, oh, yeah, they were planning on this in 2005 and they hadn't updated the launch date yet, were they still planning on 2007? And yeah, you got about as much odds as you do of buying the Brooklyn Bridge from a homeless person as you did of having a 2005 plan to launch in 2007 actually work. It's not, no one thought that was still realistic.
I don't think that that was really the date at all. So we'll have, a fun time sort of watching as we go from 2007 to 2017, about 10 years later. This was, as you say, sort of in the middle of that really interesting time where they were doing a lot of the testing and a lot of the final testing. And of course, that was also that budget issue that you mentioned earlier, which included a project redesign. And what we want to see in, of course, all of our space projects is lots and lots and lots of testing, because we mentioned earlier, of course, the Hubble Space Telescope and Beyond Committee's report, but Hubble was quite close to Earth and it was repairable. If we go out to L2, this is a far enough distance. It is not going to be feasible to send humans out there if something does go wrong. And it's
I mean,
quite
let's be
interesting.
realistic about this. Let's explore that for a second, because the
L2?
farthest we'd ever sent humans into space, the farthest was when the moon was at apogee. When the
Hmm.
moon was at its farthest from Earth, Apollo 13 launched to send astronauts to the moon. And of course, Apollo 13, famously, the astronauts did not land on the moon, but they did swing around the far side of the moon. They did swing around behind the moon. They made it to the moon and they journeyed behind it. They were about 400,000 kilometers from Earth. That's the farthest any human has ever been from Earth. JWST is 4 times that distance. It is at 1.5 million kilometers from Earth. No spacecraft that has carried a human has ever gone that far away from Earth. So we would be talking about unprecedented servicing,
Yeah.
assuming that the thing that went wrong with JWST wasn't something that prevented it from reaching that point. So, a lot of people, when they talk about the early history of JWST, they talk about it like, oh, look at this ambitious schedule that scientists set. And of course, they never made it. And they decades of delay. And it was just, no, that's an absurd way to look at this. I want to emphasize for all of you listening out there, things take the amount of time they take to get it right. And if you rush, you risk failure, which for a mission like this should not be an option. So, everyone who wishes they had it faster, absolutely,
Mm.
you do not. You do not wish you had it faster, because if you had it faster, you wouldn't have had the type of quality assurance that we wound up with. If it's all right with you, Elena, I know we have a lot planned because I see your show notes. Can we move up to the JWST launch, because we're
Oh
halfway through
yes,
and
we're
I
we're
don't
we're
want to
basically
belabor
at
all of
the
this ancient
JWS.
history?
Yes. Well, and it is interesting to note that, it was such an exceptional project in so many ways, for so many years. And of course, we'll move up to the launch because that was something that a lot of folks, including our listeners, can absolutely, probably, at least I hope they remember, 25th of December in 2021. And this was, really, really an extraordinarily exciting time. We had, of course, the pandemic coming in 2020, which put a stop to pretty much everything. But they had set 22nd of December for 2021, and there were some extra sort of exciting things happening around the JWST development because they had some additional testing, and they had a little unplanned clamp release, and they had to chase that down. And we were sort of all watching with sort of great anticipation as it was like, oh my gosh, it's looking like it's going to launch. And finally, on the 25th of December, it actually did it. And I kind of like, it's one of these, do you remember where you were when the the JWST launched? And I was like, yeah. Of course, it can now be found out at L2. And I do always like to sort of mention to folks is that they have a lovely JWST site over on nasa.gov, which has the current deployment for JWST with a lot of the fun things that you've been mentioning, Ethan. They've got the temperature for the hot and cold side. They've got cruising speeds. They've got sort of, it's the where is web calculator, so you can actually go online and see what its current distance is. And it's got some fun, not detailed enough tracking for telescope pointing, but lots of great stuff on there. And I certainly remember where I was when it launched. And I have to ask, I was looking around, but I wasn't sure. Were you able to go see this launch?
Oh, well, it was a pandemic. And despite being, the esteemed astrophysicist that you have introduced me as, no, I was not given a special invitation to go see
No,
the
no
launch
special
in
chair.
person. No, but I did, like so many people. I'm here on the west coast of North America, so I woke up at like 4 a.m. to watch the launch on Christmas morning. First time in a very long time I got up so early on a Christmas morning, and you know, it was it was so nerve wracking, right? Because
Yeah.
you're aware of all the things that could go wrong. So many things went right, to even get the telescope to French Guiana, to the spaceport there. it had to be shipped over 5,000 miles overseas. And because it was going to French Guiana at the French spaceport, it was actually escorted across international waters by the French Foreign Legion. And its path from Redondo Beach, California to the spaceport at French Guiana was kept secret because of fear of pirates. It was the French Foreign Legion that protected the telescope during that 16-day journey at sea. And then when the telescope arrived, it was shipped, it was married to the rocket. They did, of course, address any issues like the fastener that was erroneous, and so they fixed that. Then on the morning of the 25th, they have the countdown and the launch goes as planned, and you're watching the trajectory. I couldn't help but remember that the Ariane 5 rocket that they launched it from, Ariane 5 had 82 consecutive successful launches. And then the last one before JWST failed and it went off course by something like 7 degrees, which would be for JWST catastrophic because as an astrophysicist watching it, that's the big thing I was concerned about. I knew they were planning this to be a 5.5 to 10 year mission, which means they load up the JWST with fuel and they launch the rocket, and they will separate the first stage from the second stage, and then the second stage will fire. And when it's all done with its fuel, it will release the telescope. And the plan was that the telescope will, once it separates from the spacecraft, it will release its solar panels after 5 minutes. And once it gets power, then it will commit its first burns, its first course correction, so that it's on track to the L2 Lagrange point. And after doing all of those course corrections and inserting itself into the orbit, then it can, undergo the last stages of its deployment, and whatever fuel is left, you can do science operations with. And so I saw when they launched, they had this yellow trajectory that they had planned out for the rocket that you wanted it, that green line that it was actually making, to follow perfectly. Now, I don't speak French, but I did learn the French word nominal watching
Hmm.
this,
Yeah, I
because
remember that.
that is what rang out over and over, which, yes, it means nominal, but it also means all systems are looking good. And that is what kept ringing out over and over and over. And the first stage and second stage released. And then, it again looked like that green line was tracing the yellow line perfectly. And then you saw it. The moment of release happened, and they had a camera on the second stage of the Ariane 5 rocket so you could watch JWST depart from it. And it didn't take 5 minutes. In less than 30 seconds, as it was glinting in the sunlight, I saw it. I saw the solar panels start to come out. Now, some people saw that and they freaked out because they didn't know what was going on. But I knew, because I had read the plan, that there was an automatic failsafe that if JWST was already on its perfect ideal trajectory, the solar panel would deploy automatically. So when I saw that come out, that was like the moment for me, right? It just started like, that's when I started crying, because I knew, oh my goodness, we're not going to have 5.5 years of science lifetime. We're not going to have 10 years of science lifetime. We're probably going to get closer to 20 years. And the final number that I heard is between 22 and 23 years of anticipated science lifetime. So for
Yeah.
everyone who was like, oh, we could have had it sooner. Oh, we could have had it, earlier. Yeah, but would it be this good and would it last this long? Not a chance. This
Yeah,
is
this is
why
the
you
real
take the time to
artistry.
get it right, because the payoff is what we have now.
Exactly. And it's a well crafted, incredibly well tested, incredibly robust scientific instrument. It is not at all surprising that it is massively oversubscribed and in very, very high demand, because it has it really has been just solidly one win after another. Now we are at the approximately over the halfway point. So this is generally where I just go ahead and remind everyone that you are in fact listening to York Universe, broadcasting live from the Allan I. Carswell Observatory, located in York University in Toronto, Ontario, Canada. If you would like to find out more about our show or check our archives, you can always go to yorku.ca/science/observatory. And of course, while you're there, you can also check out our ongoing science fundraiser to support the observatory's repairs, refurbishments, and extra tours. Tonight, you are listening to Elena Hyde and Ethan Siegel, and we're discussing JWST, all kinds of JWST stuff. And of course, if you are navigating over live onto the YouTube channel, you will be able to go ahead and ask us any questions over there in chat. If you're catching this episode later as a podcast, for example, you can find out what the chat was all about by going over to the OPV. So a little bit of a full circle here. Now, thanks, Ethan, for bringing us around onto JWST. I think it's safe to say this is a real favorite topic with so many people, myself included. Now we have so much going on with JWST, and as you say, one of these projects that was really, really worth the effort and the work that was put into it. And I thought this would be a good halfway point to maybe redirect a little bit because I want to find out more about your upcoming JWST adventures and some of your involvement here.
Oh, well, I'm in the I'm in the cheerleader section when it comes to JWST, right? I'm not someone. I wasn't involved with designing the telescope or building the telescope or operating the telescope. I get to be a cheerleader and someone who delights in what it's doing. But that's also given me the opportunity to sort of help share the story of JWST with the world. So earlier this towards the end of the year here, my very first National Geographic book on the topic of the JWST has been published. It is called Infinite Cosmos: Visions from the James Webb Space Telescope. And if you are looking for a holiday gift for someone in your life who loves space science and the gorgeous, gorgeous imagery associated with JWST, I am very pleased to tell you that not only is this available wherever books are sold, but right now, I just checked, it is 36% off at Amazon. So feel free to, that means I think you can get a few extra copies, which I highly recommend. One of the things I love about JWST is what a truly international effort it is. They have tens of thousands of hours that thousands of scientists have devoted to it, building the instruments for it, developing the technologies for it, a whole bunch of everything, right? The Canadian Space Agency was a partner in this mission. The European Space Agency was a partner in this mission. All told, I believe there are over 140 institutions from around the world that have come together to contribute to JWST. And even though we're going to, get into some of what it's seen and what we've learned, I do want to remind everyone out there that, especially over the next few years, you're going to hear a lot of differing opinions about what the future of space-based astrophysics observing should be. And I want to remind everyone that what I told you about discovery potential, as revolutionary as JWST has been for its wavelength range, if I were to look at all of the wavelength ranges out there and say, hey, what's got the most discovery potential now? I would say there are four areas. The X ray, we have not had a better X ray space telescope than Chandra, and that is over 25 years old. Chandra was launched, I believe, more than 25 years ago. And we can build a successor and do incredible things and gain incredible science. We have never had, except for the Herschel Space Observatory by the ESA, which is now defunct. It is the only far infrared observatory we've built in space this century. If you look elsewhere, you say, well, hey, we have this optical, right? We have Hubble, right? There is still so much room to do better. That is what Habitable Worlds Observatory, which should be NASA's flagship mission of either the 2030s or 2040s, should do. If you dreamed of imaging an Earth sized planet at Earth like distances from sun like stars, we will have the technology that will be the observatory to do it. If you were like, oh, what would someone see if they looked at Earth? This will give us the technology that we could look at the closest Earth like planets to our own directly. And the last place, believe it or not, is the radio. You don't really need radio to go to space for the radio, but you do if you want to have radio signals that are free from the radio pollution that we produce here on Earth. There's only one place to go for that, and that is the far side of the moon. So I do want to emphasize that even though I'm super excited about the James Webb Space Telescope, I can't help but also look to the future and say, hey, X ray, optical, far into the radio, and also far infrared. We are just leaving science out there on the table if we don't build observatories to fill these holes and take advantage of all of that discovery potential that's available to us.
Absolutely. I can't wait to see what kind of observatories come next. I am, of course, partial to observatories, but in general. And of course, you mentioned your book coming out, The Infinite Cosmos. It does look great. I will just caution folks, if you are in Canada right now, just watch out for the postal strike. But Amazon should be able to get it to you, and they do have very, very good ratings. So it looks excellent. I know a lot of students who are big JWST fans, so I think that's a wonderful, wonderful Christmas gift recommendation as well. So do you have any, I suppose without giving away any spoilers, do you have any sort of favorites from the James Webb Space Telescope that you'd like to bring out?
I'm going to spoil a whole bunch of you out there
Oh, good.
because
Okay.
because you deserve to be spoiled, right? This is I like to think of Hubble as the telescope that showed us what the universe looks like. And JWST is now the telescope that is showing us how the universe grew up. Hubble has given us a variety of great snapshots, but JWST can see farther back into our cosmic past than any other optical or infrared observatory in history. Its ability to observe longer wavelengths than ever before at such high precision, plus its ability to conduct spectroscopic follow up, allows it to identify enormous numbers of galaxies that go far beyond what Hubble could see. The farthest galaxy we knew of prior to JWST's launch was GNZ11, which was the most distant galaxy ever known, and it was discovered by Hubble back in 2016. Today, GNZ11 is not even in the top 10 of most distant galaxies because JWST holds all of the top 10 spots. The farthest distance it's found is called JADES GSZ 14-0, whose light comes to us from just 285 million years after the Big Bang, when the universe was just 2.1% of its current age. It also remarkably overlaps in space with a brighter foreground galaxy along the same line of sights. But thanks to JWST's resolution, it can tell that it's two galaxies at two different distances. which is amazing. JWST has broken a bunch of these cosmic distance record. It didn't just discover the most distant galaxy or the 10 most distant galaxies. It also discovered the earliest cluster of galaxies that's forming just 650 million years after the Big Bang. It has found the most distant gravitational lens ever discovered. It also found the most distant supermassive black hole ever discovered. But what I love the most about JWST was the stuff it found that surprised us. We
Oh,
got
yeah.
surprises with JWST. One of the biggest surprises was with these early supermassive black holes. We had this question of what came first, the stars in galaxies or the supermassive black holes in the centers of galaxies. And we had thought, okay, look, the stars probably come first, right? You form neutral atoms and gravity works to collapse them, and at some place it'll collapse and you'll start making stars. Guess what? That can't be the whole story, because the James Webb Space Telescope found a galaxy, and it did this by teaming up with the Chandra X-ray Observatory. These things are better together. These observatories do a better job when they work together because each one can see things the other can't. So Chandra was excellent at measuring the black hole in an early galaxy and said, "Oh, look how big you are. You're 9 million solar masses. How interesting." And then we said, well, hey, with JWST, we could also look at this galaxy and see how many solar masses worth of stars are in there. And the answer is less than 10 million. Well, we don't have anything like that today. If you take a look at the biggest supermassive black holes, there's 1,000 times as much mass in the form of stars as there are there, as there are in the black hole. So if you look early and you say, "Ooh, look, the black hole was bigger compared to the rest of the galaxy," that tells you it didn't form from stars. Somehow, at least a seed for a supermassive black hole formed independently of these stars. That is a huge discovery that we weren't even sure was the right question to ask. But JWST, in conjunction with Chandra, showed us it was real. Another surprise that I thought was just wonderful is, yeah, okay, we're going to look in the Orion Nebula. It's the closest large star forming region to Earth. Of course, you're going to find all these protostars to image. You're going to map out the neutral matter and the dust. And yeah, it did all of those things. But while it was doing those things, it found something it wasn't expecting. It found an enormous number of Jupiter mass planets that were freely floating, planets without parent stars of any types. And not only was the discovery of these planets a surprise, but it turned out that 9% of them, a whopping 1 out of every 11 of them, were bound together in binary pairs where you had two Jupiter mass binary objects, or jumbos, because astronomers love acronyms, Jupiter mass binary objects, a class of object that we didn't even know existed prior to JWST. But my favorite thing, my favorite surprise, was JWST took a look at the nearby star Fomalhaut. Fomalhaut is one of the brightest stars in the night sky. I think it's the 21st brightest star as seen from Earth. It's also one of the youngest stars that is close to Earth. It is only a few 100 million years old, so young that it still has a debris disk around it. Well, Hubble had imaged it and found there was a ring of debris. And we looked at that and said, "Ooh, look at that. It's an analogy of our Kuiper belt here in another star system." Well, JWST took a look at it and said, well, not only do we have that outer Kuiper like belt, and not only do we have an inner disk which has, something analogous to our asteroid belt within it, but there is a third intermediate belt in there. Who ordered that? we had assumed for generations that stellar systems that formed would be like ours. They would have planets, an asteroid like belt, more planets, and a Kuiper like belt. And what we now are thinking is, well, now we don't even know if two is the typical number of belts. Is two or three more common? Are those the only options? Or can you have one? Or can you have four? Or can you have even more belts? That's my favorite stuff. That's what I mean by discovery potential. Is sure, you can say, well, we built it to find the most distant objects and we did. Hooray. That's exciting. It's super exciting. But that's not all the science you get. Sometimes, just because you dared to look at the universe in a way you've never looked at it before, you have the opportunity to find things that you couldn't have even imagined.
Absolutely. And of course, we're seeing JWST in the news, I think, every month now for new amazing images. I recall the that new Sombrero Galaxy image has recently come off the presses. I believe if it's not the APOD, it should maybe should be. But it
It's my like APOY. It's like it's one of my astronomy pictures of the year. The Sombrero Galaxy, for those of you who've never seen it, is this weird hybrid. It has features of a spiral galaxy and it has features of an elliptical galaxy all in one. It has this bright, dusty disk, almost edge on, and this huge central bulge. And yet, when you look at it with JWST, you can subtract out that bulgy elliptical light and instead you highlight the gas and dust that are working to form new stars. And what you find is at the center of the sombrero is an extremely bright central disk, followed by a very, very sparse area that has almost no star forming material in it. And then there's a big ring around it. The ring has a warp in it. The ring is tilted at about 7 degrees to us, but that is where almost all of the new star formation is happening. And if you take a look at this image for yourself, you can get it for free from the JWST site, which I highly
yes.
recommend you do. ESA has it, Space Telescope has it. Zoom
Yeah,
in to the full
science.nasa
resolution
has it
image.
too. It's all
Um,
over.
because if you
Um,
zoom into the full resolution image, you can see that behind the Sombrero Galaxy with JWST, you can see hundreds, if not thousands, of background galaxies beyond it. JWST is exquisite. There has never been a better observatory at imaging these the greater universe, even behind the objects of interest that it's looking at.
Yeah, it's been just so great to see it coming through, and we unfortunately haven't even had time to talk about, of course, the exoplanets really, which again, if we're talking about recent news, I believe was it just this
The
month they
Kepler
had a new
51
planet.
system
Yep,
has a new
a
exoplanet. It
new
had an
planet.
exoplanet that we didn't even know to look for. But because, again, we looked at it doing completely other science with JWST, we were able to say, oh my God, look at the teeny tiny little flux dip. And now, bam, new exoplanet in this system.
Yeah, exactly. And so the more we see, the more we find, I suppose. And the more we
Yeah.
find, the more excited we get. And of course, all of this is possible due to the amazing the amazing development of this telescope and the really unique instruments, which actually we haven't really had a chance to talk about in this episode, but I would encourage folks to go up and read a little bit about these infrared instruments, the NIRCam and MIRI, because they're really
Good news,
quite
they are in depth gone into in the book Infinite Cosmos because,
excellent. Thank
in
you. That
just
was
an
going to be
hour,
my
we
next
don't have
question.
time to talk about everything, but in a book, you can do much, much more.
Amazing. So if you want to hear more, you don't have to take it from me, but you can find it in Ethan's new book. And it does, of course, have excellent reviews over on Amazon. That's Infinite Cosmos Visions from the James Webb Space Telescope. Now, we do have to wrap up this episode, although I'm sure we could talk about JWST for several more episodes, and we probably will at some point soon. But thanks everyone for joining us this evening. You all have been listening to York Universe, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Ethan Siegel from Starts with a Bang fame, and please do check out his new book over on Amazon, The Infinite Cosmos, Visions from the James Webb Space Telescope. And of course, you can find out more about his blog and his website and all of his amazing science writing just by looking him up online. Now, everyone, thank you very much for joining us this evening. And if you do want to check out the Allan I. Carswell Observatory fundraiser or any of our exciting archives, check out our website at yorku.ca/science/observatory. Unfortunately, it has been cloudy this evening, but I'll wish you all clear skies anyways. Thanks for tuning in and have a great night.